Okay, so this is where we stopped yesterday. So yesterday we completed number 4. So we are going to continue with number 5. Lithium-ion battery is commonly used in many digital devices such as handphone, laptop, and media player. The reaction occurring in the battery involved can be expressed by the following standard electrode potential. So you have Li plus E minus give Li solid. E naught is negative 3.05. Then Li plus COO2 plus E minus give LiCOO2. So E naught is positive 0.40. A. Explain the reactions occur and write the overall reaction equation for the reactions in here. So when they say lithium ion battery in here, so this is supposedly you are making use of the lithium as the sources of the battery to become the lithium ion. Then the lithium ion will react with the COO2. So the first equation in here, you should be reversed. So lithium will undergo oxidation. Okay, lithium will act as the anode of the cell, which will undergo oxidation, whereas lithium cobaltate, LiCOO2, act as the cathode of the cell. Okay, where it undergoes reduction. So you try to complete your sentence by writing it undergoes oxidation and reductions. Okay, so equations for the reactions in here is written as Li plus CO2 give LiCO2. Now, if possible, because the question in here also give the state of matter, so I would usually advise you all to also write the state of matter in here. Okay, so just in case that if they really wanted the state of matter, okay, to be written. Okay, B, calculate the electromotive forces of this cell. So you use 0.4 minus negative 0.5, 3.05, so you get positive 3.45. So in here, the positive sign must be insisted because the positive negative in the E naught value is important. Okay. Okay, number 3, state the advantages of the lithium ion that suits to its many digital device. Number 1, as you can see, it provides a large voltage. Okay, it provides a large voltage. It is rechargeable and it is lightweight because lithium, for your information, is the lightest metal in the whole periodic tables. Okay, lightest metal in the whole periodic table. So that is why a lot of this digital can be carried very easily. Okay, because of the lightweight of the lithium. Okay. Okay, so with that, that is how you answer for question number 5. Then we goes to question number 6. Strontium metal can be obtained by the electrolysis of molten strontium 2 chloride, SrCl2, using the apparatus shown in the diagram. Okay, so write an equation including state symbol for the electrodes reaction in here. So because they are already molten, so you must write in liquid. So 2Cl minus liquid gives Cl2 gas plus 2E minus. That is for anode, and then for cathode, you have Sr2 plus 2E minus give Sr. Okay, so that is the half equation for what happened at cathode and anode respectively. B, explain why an atmospheric argon is used around the cathode. So in here, because you are going to put the molten strontium, so strontium is very reactive with the oxygen gas. So that is why you put an argon as the layer to prevent the reaction between oxygen and also the argon gas in here. Okay, so to prevent the air or prevent oxygen to filling in the space and hence react with the strontium metal. So that is how you are going to answer for number 6B in here. As for 6C, a current of 4.50 ampere was passed through the molten strontium chloride for 60 minutes. Calculate the mass of the strontium metal formed given Faraday constant 96,500 coulomb per mole electron. So first of all, you calculate the quantity of charge Q equals to IT. So 4.50 times 60 times 60, so you get 16200. Then mole of electron is 16200 divided by 96,500, you get 0.168 mole of electron. So since 2 mole of electron is stoichiometry to 1 mole of strontium, so you can look at the half equations back there. Okay, so mole of strontium divided by 2, you get 0.0839. And finally, you can calculate the mass of the strontium form. So 0.0839 multiplied by 87.6, you get 7.35 grams. So that is how you calculate the mass of the strontium that is produced out of this current and this voltage. Okay, so D, explain why aqueous strontium chloride cannot be used to extract strontium by electrolysis, because in the aqueous strontium chloride you have water, so water will be reacted. So either you say strontium is electropositive, so water is discharged preferentially because inert value is less negative. Okay, so that is how you explain why you have to use molten strontium chloride instead of the aqueous solutions one. Okay, so if not, water will be selected to discharge. Okay. Okay, so that is how you solve question number 6. Then we goes to question number 7. Nickel-cadmium cell used in one type of rechargeable battery consists of a nickel electrode and a cadmium electrode, so immersed in the potassium hydroxide. So using under normal use, the cadmium electrode release electron to the external circuit. So the relevant electrodes reacts are given below. So you have cadmium hydroxide plus 2E minus gives cadmium plus 2OH minus, and then you have NiOOH plus H2O plus E minus give NiOH2 plus OH minus. So E naught is negative 0.68. So you have to reverse the one which is the second equation eventually, so that you can get a redox reactions in here. Okay, so the flow of electrons in here, very obviously cadmium in here because it is positive. So the positive indicates that it will act as the cathode of the cell. Okay, and the negative in here of the nickel in here will indicates that it will act as the anode of the cell. Okay, so the electron flow from the anode to cathode, which is from the nickel cathode to the cadmium anode. Nickel anode, cadmium cathode. Sorry for that. I mixed the structure. Okay, okay. So that is how you get for question number A. Then B, write a balance equation for the reaction that occur during the discharge. So in here, you compare based on the 2-half equation. So you have CdOH2 2 plus NiOH2 gives Cd plus NiOH plus H2O, and calculate the EMF of the cell produced. So you have 0.74 minus negative 0.68. So you get positive 1.42. And finally, for D, write the cell diagram for the nickel-cadmium cell. So in here, the question already clearly give you what are the state of matter inside them. So they also give you the electrode is nickel and cadmium. So the cadmium hydroxide and nickel hydroxide will act as their respective layered structure inside the electrolyte in order for the redox reaction to take place. So that is how you do this one. So the EMF of the cell is E cathode minus E anode, or positive 0.74 minus negative 6.8. So therefore you get 1.42 volt. Okay. Okay, last but not least, write the cell diagram for the nickel-cadmium cell. So you have Ni solid, NiOH2, NiOH, because they are in the same state of matter. So if they are in the same state of matter, so you're supposed to use the common in here. Okay. Give CiOH2 plus CD. Okay. Okay, so with that, that is more or less of how you solve question number 7. Okay, so with realization, let's move to question number 8. Okay, question number 8 sounds like this. The following cell was set up between a copper electrode and unknown metal of M2 plus M. Then the electrode potential was found to be 0.76. And the copper foil is positive terminal of the cell. So that means the unknown metal is the anode of the cell. So number 1, given the E naught value of the copper 2 plus copper, E naught is positive 0.34. Calculate the standard electrode potential of M2 plus M in the system. So here you have to use the cathode minus E naught. Okay. So when you substitute the E naught cell value 0.76 plus 0.34 minus E naught of anode. Okay. So at the end of the day, you get E naught anode is equals to negative 0.42 volt. Okay. In this case, we're looking for E naught for the anode. Okay. Okay, so that is for A1. Then we straight away goes to A2. Draw the arrow diagram indicates how the electron flow inside here. So it is from the unknown matter to the copper foil. Okay, so that is how we are going to indicate the flow of electron and also how to increase the value inside them. Okay. Okay, so then we have 8B. Draw an arrow of the over the voltmeter symbol in the above diagram. Okay, also draw already. Number 3, write the cell diagram for the chemical cell above. So you have M solid, one line, M2 plus aqueous, double line, Cu2 plus aqueous Cu. Okay, because they are all metal hydroxide, metal oxide and hydroxide species. So just a simple setup is enough already. B, predict the outcome of the following situation. Describe what you might see and write the ionic equation for any reaction that takes place in here. So A, a rod metal of M is dipped into a solution of copper 2 sulfate. So what will happen if you add into a solution of copper 2 sulfate? So either you say M corroded in copper 2 plus or blue solution faded. And then write the overall equation. M plus Cu2 plus give M2 plus Cu. Okay, so that is the second mark here. And number 2, dilute sulfuric acid is added to the beaker containing a powder of center metal M. So what will happen to the observation? So you expect effervescence, okay, bubbling. M plus 2H plus give M2 plus H2. That is for the positively charged ion. You displace the hydrogen gas. Okay, so with that, that is all for the questions for structure. So with that hesitation, let's straight away move on to the essay questions, shall we? Okay, so we are going to have a look at a few essay questions and then we are going to learn how to solve it one by one. Okay, question number 1 sounds like this in the essay. A current of 1.0 ampere is passed through potassium sulfate, K2SO4, aqueous solution for 40 minutes at 25 degrees Celsius using graphite as electrode. Calculate the total volume of gas and the cathode at the pressure 101 kilopascal. Can you hold on for a while? Sorry. Okay, so a current of 1.50 ampere is passed through potassium sulfate, K2SO4, aqueous for 40 minutes and 25 degrees Celsius using graphite as electrode. Calculate the total volume of gas at the cathode at the pressure 101, at anode and cathode at the pressure 101 kilopascal. Okay, so first of all, you need to deduce what is the product given off by potassium sulfate. So you have to deduce by using the electrolysis. So since K2SO4 aqueous contain K plus SO4 2 minus and also H2O, so the expected product of the electrolysis is at anode, you must have H2O give 4H plus plus O2 plus 4E minus. No need to explain until the extent because this is, after all, the questions to ask you to calculate volume of gas at the end of the day. You just need to estimate what is the product of electrolysis by writing the suitable half equations. And then half equation at cathode is 2H2O plus 2E minus give H2 plus 2OH minus. Okay. Okay, then you use the Q equals to IT or Q equals to 1.50, substitute as exactly given to you in the questions. So 1.50 times 40.0 times 60, so you get 3,600 column. Then you divide by the Faraday constant, so 3600 divided by 96,500, so mole electron is 0.03731 mole. Okay, so then you have to compare to both of the anode and cathode by using the mole of electron. So at anode, so mole of oxygen stoichiometrically 1 to 4. So mole of oxygen is 0.0399326. And then the volume of the oxygen 0.003926 multiplied by the molar volume of gas, which is 24.4 decimeter cube per mole. So you get 0.2276 decimeter cube. As for the cathode, mole of hydrogen, you divide by 2 because stoichiometrically 1 to 2. So a mole of the hydrogen is 0.01865. Then you multiply with the molar volume of gas, 24.4, you get 0.4551, and then finally you sum up. So 0.02276 plus 0.4551. So at the end, you get your volume 0.683, 3 significant figure. Okay, so I forgot to stress. If you look carefully, it's not 27, it is 683 in 3SF. Okay, again, you can leave your answer as decimeter cube. as long as the answer has 3 significant figure. Okay, because why 1.50 lah, 40.0 lah, okay. So all of these are trying to tell you that your final answer should be in 3 significant figure. Okay, so 0.683. Yeah? Okay, so that is how you solve for question number 1A. Okay, immediately we go to the second question, 1B. Regia aqua is a mixture of the one part of the concentrated nitric acid and 3 parts of the hydrochloric acid. This mixture is used to dissolve inert metals such as gold and silver based on the following equation. 4H plus 4Cl2 give NO3 minus plus Au give AuCl4 minus plus NO plus 2H2O. Okay. Okay, so number 1, explain how regia aqua solution react with the gold in here. So the regia aqua in here is referring to the gold in here. So how does the gold changes the oxidation states in here lah? Okay, so in this case, if you notice carefully, oxidation state of the nitrogen is +5, Cl is -1, hydrogen is +1, then gold in here is 0 lah. So after the changes, so AuCl4 minus, so this one become +3, nitrogen in here become +2, water in here still you have H plus and also O2 minus. Okay. Okay, so basically it's the reaction between gold and the nitrate ion. Okay, so explain how regia aqua solution react. So first, either you say that nitrate or nitric acid is reduced to nitrogen monoxide. Okay, while gold is oxidized to become gold 3+, easier for transportation. So gold comes in the complex ion of AuCl4, then you become AuCl4 minus, AuCl4 minus. Okay. Okay, and last but not least, which is soluble in water. Okay. Okay, I admit that this is a little bit difficult to tackle on how the aqueous regions with the gold here, and definitely there's, if we're to discuss again, there will be a better alternative methods, but that is what they accepted at that year. Okay, so you just play along with it. This is actually modified from Stpm year 2003, if I'm not mistaken. Okay, then we go for number 2. Calculate the mass of gold dissolved when 48.8 centimeter cube of nitrogen monoxide is released at 25 degrees Celsius, 101 kilopascal. So you calculate the mole of gold is equals to the mole of nitrogen monoxide. So it's equals to 48.8 centimeter cube divided by 24,400. You get 0.02. So mass of gold is stoichiometrically 1:1. So mass of the gold is 0.02 multiplied by 197, you get 0.394. Okay, so that is how we are going to calculate the mole of the gold here. Okay. Okay, so that is for question number 1. Immediately we go to question number 2. Deduce the spontaneity of a chemical reaction using a relevant standard electrode potential. Okay, so this question is a little bit challenging because you need to find the Chap equations that is suitable for the reactions by using the E0 value. So the E0 value can be found at the behind page or behind page of the notes or the books that you bought through me. Okay, so you can see the series of the standard electrode potential. However, in Stpm, they don't give you the standard electrode potential table. When they want to ask you something in regards with the standard electrode potential, they will give you the value straight away inside the question, what it is. Okay. Okay, so I hope that you will understand. Okay, start from number 1. Aqueous tin 2 chloride, we have acidified aqueous hydrogen peroxide. So basically, you have SN2+. React with the concentrated sulfuric acid H++. H++ H2O2 acidified hydrogen peroxide. Okay, so you need to find from the data booklet. One of them is at the left side, another one is at the right side. And if you look carefully, acidified hydrogen peroxide can only do reduction. Therefore, tin must be doing oxidation. Okay, tin must be doing oxidation. So how do you calculate in here? So H2O2 plus 2H plus 3 minus give 2H2O. And then let's have a look at the reactions by the tin. So you have tin 2 plus gives tin 4 plus 3 minus. So standard electrical potential in here is negative 0.37 volt. So you must, when you choose the suitable half equations, one equation must be at the left side, another equation must be at the right side. Okay, so try to bear that in mind. So then you write the half equations in here and overall Enoch cell value. So for me, for me, this is just the way of how you are going to find the suitable half equation method. So you need to practice as much as you can. Okay. Okay. So that is for 2A1. Then we goes for 2A2. Acidified aqueous sodium dichromate and chlorine aqueous solutions. So your reactant now is in between Cl2 and also dichromate. Cl2O72 minus. Okay, chlorine is Cl2. So this one is guaranteed doing a reduction. So therefore, Cl2 is doing an oxidation. Okay, so in here, when you check the suitable half equation series, there's only one toward it. It's the one half equation in regards to the Cl2O7 is Cl2O72 minus plus 40H plus AA minus. Give 2 Cl3 plus 7 H2O. Okay, then Cl2 plus 2H2O give 2 HOCl plus 2H plus 3 minus. So this dichromate is doing reduction, while chlorine must be doing oxidation. So that is the principle. So as a result, when you write the overall valence equation, Enoch cell is negative, Enoch is 0.30 negative. And since Enoch cell is negative, reaction is non-spontaneous. So that is how you deduce whether a reaction is spontaneous or non-spontaneous in here. Okay, so that is for number 2. Then we go for number B. Standard electrode potential of potassium, calcium, and chlorine are negative 2.92, negative 2.87, and positive 1.36 volt respectively. Explain the difference in the oxidation state, oxidation reduction properties of this element based on their starting materials in the standard electrode potential. So how are you going to solve this? So you have to first explain what is the ability of oxidizing and reducing agent. So in here, you have to mention because it's negative. So potassium and calcium are reducing agent, while chlorine is an oxidizing agent. Okay. So when you have two or more at the same category, they ought to be representative. So the representative in here, we can explain by using K give K plus E minus, or Ca give Ca2 plus 3 minus, means that they are electropositive metal that are ready to donate electron. However, since potassium has a more negative Enoch value, so potassium is a stronger reducing agent compared to carbons in here. Okay. So why? Because Enoch value is more negative. Okay. Okay. So finishing explaining about this potassium, calcium, we are going to have a look at chlorine because chlorine is positive 1.63. So the positive 1.36, sorry, positive 1.36 indicates that Cl2 is an oxidizing agent. Okay, so according to the equation, Cl2 plus 3 minus give 2Cl minus. So positive Enoch value shows that chlorine is a strong oxidizing agent. So that will be all for what you need to explain whenever you are meeting on such questions. Okay, I'm not surprised if this come up again. Okay. Okay, so with that, that is for how you answer for question number 2. Immediately we goes to question number 3. Okay, with the aid of diagram, describe how you measure the standard electrode potential of zinc half cell. Okay, so 6 marks in here. So you have to label everything. You try your best to label everything. Include the first one is the how to draw the setup of the half cell for standard hydrogen electrode, first mark. Then the second mark goes to how to draw the standard hydrogen standard electrode potential for zinc. So you must have zinc plate immersed inside a zinc sulfate at concentration 1.0 at mole per decimeter cube 25 degrees Celsius. As for standard hydrogen electrode, you must using pure hydrogen, okay, at 1 atmosphere. So try your best to write at what pressure it is. Okay, so this is it. And then the down here you have the platinum as the electrode, and then the acid, okay, at the concentration 1.0 mole per decimeter cube at 25 degrees Celsius. And then you also don't forget you must also label this one salt bridge, okay. And then you also have potentiometer. Okay, one more to forget to mention that you must always have this arrow who goes to who, so that you'll be will give you more marks inside the diagram. Okay, so try your best to label as complete as you can. And also, last but not least, these Enoch values in here. So try your best to describe as fully as you can, like I told you. Okay, so with that, that is how we solved for question number 3A. Okay, by the way, in here, not yet, sorry. There are still way of how you, this one, describe. Okay, so in here, the diffraction, okay, since Enoch cell, this one I'm not yet finished, I'm not yet complete. So you must also describe, since this Enoch cell equals to Enoch cathode minus Enoch anode. So positive 0.76 volt is equals to 0 minus Enoch anode. So as a result, Enoch anode is equals to negative 0.76 volt. Because negative switch, then it become negative here. Okay. Okay, so that is how you are going to calculate for the zinc half cell. What is the EMF for the zinc half cell? Okay, then we goes to the last question of number 3, which is 3B. Aqua solution of silver 1 nitrate and aqua solution of magnesium nitrate are separately electrolyzed using inert electrode. Based on the standard electrode potential, explain how this electrolyzes and write the equation for all the reactions involved. So I would recommend you all to do in the form of table, and you still remember the technique of how should I teach you how to answer. You must have species that is involved, find the suitable standard electrode potential and compare their value. At anode, we choose the one which is the more negative or least positive. And then at cathode, we choose the one which is more positive or least negative. Okay, so and then you try to write down why is it happening? Okay, what are the subparticles responsible for it? Okay, so let's say for silver nitrate, you contain silver ion, nitrate ion, and water. On zinc nitrate, it's not zinc, magnesium. Sorry, typing error. Okay. Okay, so electrolyzing silver nitrate will give silver at cathode, oxygen at anode. Silver is silver, not copper. Silver is deposited at cathode due to Enoch value is more positive. Okay, silver is deposited because Enoch is more positive than water. So the half equation at the cathode is Ag plus, not Ag2 plus. Why so many typing error? Sorry. Okay, so half equation occur at cathode, Ag plus E minus if Ag, and then the other one is electrolysis of magnesium nitrate produces hydrogen at cathode and oxygen at anode. So hydrogen deposited at cathode, since E naught value of water is less negative than E naught of the magnesium. So according to the half equation, 2H2O plus 3 minus give H2 plus 2OH minus. And then anode oxygen is produced since inert value of water is positive 1.23, which is more negative than the nitrate ion. So as a result, the nitrate ion's half equation goes like this: 2H2O plus O2 plus 4H plus 4E minus. Okay. Okay, so I guess that will be all for our discussion for today. So you try your best to write down to complete the essay for number 4, 5, and 6, and we shall continue our discussion tomorrow. Okay, so I think I'm